Welcome to our presentation, MotifClass Weekly Supervised Text Classification with Higher-order Metadata Information. I'm Zhang from UIUC. This is a joint work with Shweta, Meng, Xiusi, and Professor Jiawei. So first, let me introduce the motivation of our project. Our task is Weekly Supervised Text Classification, which aims to classify documents into a set of predefined categories with category names as the only supervision and without any annotated training document. This setting actually eliminates the needs for human annotations given a new domain or some emerged categories. Instead of just considering the text information, we observe that in various domains, documents are beyond plain text sequences and are accompanied by different types of metadata. For example, a research paper has its authors, venue, and published year. An e-commerce review may have its user and product information. These metadata, together with text, provide better clues of the interrelationship between multiple documents, so they are useful for inferring their categories. For example, in the figure, the venue neighbor EMNLP actually indicates Doc1's relevance with natural language processing. There have been some existing studies on weakly supervised metadata-aware text classification. However, they are usually less concerned with two factors. The first factor is higher-order metadata information, also known as motifs in network science. Different types of metadata should be considered collectively in classification. For example, the combination of AAAI and 1990 is a strong indicator that the paper belongs to traditional artificial intelligence. In contrast, either the year or the venue alone becomes a weaker signal. To give another example, in our figure, document 2 has two authors. If you check their publication lists, you can find that neither of them alone is enough to predict the category social computing, but their co-authorship becomes category indicative. The second factor is metadata specificity. To suggest the category of a document, a motif instance should be not only semantically close to that category, but also specific enough to indicate only one category. For example, still for document 2, its venue CSCW may be linked with many papers related to social computing, but purely relying on CSCW or even the venue plus the year will introduce noises because these motifs are broader than the category itself. Also, for document 1, we can see that the term language is too broad to predict natural language processing. Therefore, in this project, we aim to consider both higher-order metadata and metadata specificity in weakly supervised text classification. Before that, let me first introduce some notations. We assume the text of each document is a sequence of terms. Here, terms refer to words or phrases. And the document metadata refer to some node types, for example, author or venue. Each metadata has its instances. And the motifs refer to some subgraph patterns in the network. Because we are doing document classification, we focus on motifs with one document node only. We provide some example motif patterns used in an academic paper corpus. For example, the third pattern from the left is a document node linked with a venue node and a year node. And the fourth pattern from the left is a document node linked with two author nodes. Similar to metadata instances, each motif also has its motif instances. And the formal definition of our task is that given a set of unlabeled documents with metadata, the surface name of each category, and a set of candidate motif patterns given by users, we aim to assign a label to each document. To solve this task, I will then briefly introduce our MotifClass framework. We lay out the MotifClass framework here. The general idea of MotifClass is that because we don't have any human annotated training data, we aim to use category names and higher-order metadata to create pseudo-labeled training data. So we have three modules here: indicative motif instance selection, pseudo-labeled training data collection, and text classifier training. I will then introduce them one by one. The first module is indicative motif instance selection. For each category, we aim to select category indicative motif instances based on their similarity with the label surface name, as well as their specificity. To implement this goal, we propose a joint representation learning method to learn the motif instance embedding vector EM and the motif instance specificity kappa M, which is a scalar, simultaneously. For more mathematical details of our joint representation learning step, you can refer to our paper. The second step is to collect pseudo-labeled training data. We propose two strategies, retrieval and generation. In retrieval, by matching unlabeled documents with selected motif instances, we can retrieve documents that likely belong to a certain category. In generation, based on the motif-aware text embeddings learned in the joint representation learning step, we generate artificial training documents. The two strategies are complementary according to our experiments. The third step is to train a text classifier using the collected pseudo-training documents, where the input sequence to the classifier is the concatenation of metadata information and text. Our MotifClass framework is compatible with any text classifier. Here we use the simple convolutional neural networks proposed by Kim. Now let me present our experimental results. We conduct experiments on two datasets. The Meng CS dataset is a collection of research papers in the CS domain, and the Amazon dataset is a collection of e-commerce reviews. Our baselines include weakly supervised text classification method based on text only, text plus metadata, or pre-trained language models. We also include heterogeneous network embedding approaches as our baselines. And because higher-order metadata and metadata specificity are the two factors considered by us in this project, we also include two ablation versions, no higher order and no specificity, into comparison. According to the experimental results, we find that, first, MotifClass consistently achieves the best performance. In most cases, the gap between MotifClass and the baselines is statistically significant. Second, we find that the full MotifClass model outperforms no higher order and no specificity on both datasets, which validates our claim that both factors considered by us are helpful. Now let's have some deeper analysis of the two factors. We start from higher-order metadata, where we have two observations. First, we calculate the proportion of each motif type in selected motif instances on Meng CS. The results are shown in Table 3, where we find that higher-order motif instances actually cover a large proportion of the selected instances. Second, we calculate the accuracies of pseudo-labeled training documents retrieved by the full MotifClass model and the MotifClass no higher order. The results are shown in Figure 5, where we can observe that higher-order motif instances can actually improve the quality of retrieved pseudo-training data. Now we show the benefit of considering metadata specificity. In MotifClass, we require the selected motif instances to be at least twice as specific as the category name, so that it likely indicates only one category. We show three categories here: database, data mining, and information retrieval, as well as motif instances close to each category at different specificity levels in the embedding space. We can see some very general instances here in red, for example, the venue CIKM. Although it has many database, data mining, and information retrieval papers, it is too general to indicate any of the three categories. Therefore, it is not selected by MotifClass. Instead, we will select many higher-order motif instances which are specific enough. To conclude our paper, we propose to study weakly supervised metadata-aware text classification from the network perspective, where we identify the importance of modeling higher-order metadata and metadata specificity. We propose the MotifClass framework that discovers indicative motif instances for each category to create pseudo-labeled training documents. Experiments demonstrate the effectiveness of MotifClass as well as the utility of considering higher-order metadata and specificity. That's all for my presentation. Thank you.